This is Chapter 13.2, Mining. Believe it or not, rocks, minerals, and the minerals that can be removed from them are valuable resources, but they can be tricky to find because most of these resources are hidden beneath the surface of the ground. Locating mineral resources and fossil fuels can be scavenger hunt. Mining companies hire geologists who know the clues that may lead to a particular resource. But until the excavation begins, no one knows for sure exactly what and how much of it will be found. What is mined? Mining involves breaking into the ground to gain access to minerals, fossil fuels, or water, and extracting them. These resources are used in building materials, wiring, appliances, clothing, fertilizers, and an endless list of other goods. Without these resources, civilization as we know it would not exist. Although the Earth has an immense supply of resources, they are not all accessible. Some minerals, such as silver, are widespread throughout the crust, but in such low concentrations in many places that mining is not economically practical. In other words, it would cost more to get the resources out than the resources are worth. One of the goals of mining is to locate areas of concentrated resources. Figure 7 shows the process by which minerals are mined and used. Here's Figure 7. So we have Earth, and then areas are explored, resources are extracted, and there's waste that has to get thrown away. Minerals are refined and processed, so that's when you take whatever rock or stuff you got out of the ground and you take out of it what you are trying to get, and you have waste. And then you need to take that and refine it even further to make it nice and clean. Again, you've got garbage or waste to go. And then that's when you make your materials to make products such as cars and appliances. And again, you have waste. You also can take these and recycle them, and that takes you back up to this step 3. Metallic minerals. Most mined metals are part of minerals or groups of minerals. A mineral or group of minerals that is mined so that a metal or metals can be removed from it is called ore. Most ores are a mixture of desired materials and rocky materials that have no value, which is discarded. For material to be considered ore, the concentration of a mineral must be of a certain level, or mining it would not be economically feasible. Copper, iron, lead, gold, silver, and aluminum are among the valuable metals removed from ores. The tantalum used in high-tech devices is a metal that comes from the mineral tantalite. In nature, tantalite is often found with the mineral columbite. The ore that contains these two minerals is called coltan. Non-metallic minerals, so the stuff that's not made out of metal. Many types of minerals are mined because the mineral as a whole has valuable properties. Non-metallic minerals may actually contain metal as a chemical component, but they are not mined for the metal. For example, sand and gravel may contain aluminum and iron, but these minerals are mined because they are valuable construction materials and not for the aluminum or iron. In 2008, $7.6 billion of sand and gravel were mined in the United States alone. About 44% of sand and gravel was used to make concrete. Other valuable nonmetallic minerals include limestone, salt, and gemstones. About 100 minerals are considered gemstones, including garnet, topaz, turquoise, and jade. Fuel and water. Substances used for fuel sources are also mined. The metal uranium, which can be used to generate nuclear power, is extracted from uranium ore. One of the most common mined fuels is coal. Coal is mined in ways similar to minerals. Other fuels, such as petroleum, natural gas, oil sands, and methane hydrates, as well as groundwater, are also extracted from Earth. The methods for mining these substances will be discussed in other chapters. Mining methods. Once a good source of a mineral is found, mining companies use a variety of techniques to extract the resource from Earth. Each technique has costs and benefits for the mining industry, the environment, and people living in surrounding communities. The environmental and social impacts of mining will be discussed in the next lesson. This is page 400. Strip mining. When a resource occurs in a shallow horizontal deposits near the surface, the most effective mining method may be strip mining. During strip mining, layers of surface soil and rock are removed from large areas to expose the resource. After heavy machinery removes the soil and rock, the resource is extracted. Then the soil and rock are replaced. Strip mining is commonly used to mine coal, sand, and gravel. Subsurface mining. When a resource occurs in concentrated pockets or seams deep underground and the ground allows for safe tunneling, mining companies pursue subsurface mining. In subsurface mining, vertical shafts are dug deep into the ground, and networks of horizontal tunnels are dug or blasted out to follow deposits of the resource. Miners remove the resource and transport it out of the mine. Subsurface mining is used for metal. Subsurface mining is used for metals such as zinc, lead, nickel, tin, gold, copper, and uranium, and for non-metallic minerals such as diamonds, phosphate, and salt. A great deal of coal is also mined using this technique. The size of some subsurface mines can be mind-boggling. Certain gold mines in South Africa extend nearly 4 kilometers into the ground. So we have strip mining, which is you take the top of the ground off and then just dig out whatever's on top after that and then put the dirt back. Subsurface mining is, think of it like you're a gopher digging a hole and trying to find what you're looking for. And those go really deep into the ground. Open pit mining. Open pit mining, when a mineral is distributed widely and evenly throughout a rock formation, or when the ground is unsuitable for tunneling. The method of choice is open pit mining. Open pit mining involves digging a large hole and removing the ore and the unwanted rock that surrounds the ore. Figure 8 shows one of the biggest, if not the biggest, open pit mines in the world. Bingham Canyon Mine near Salt Lake City, Utah. This mine is about 4 kilometers wide, 1.2 kilometers deep, and has been seen from space by astronauts. Conveyor systems and immense trucks with tires taller than an average person remove nearly 500,000 tons of copper ore and waste rock each day. So this is your uh, open pit mining. It's literally dig the biggest hole you could possibly dig. And then you have to get all this stuff out. So you can see that they have a road that kind of goes around and around and around to get the trucks out. Figure 9, mountaintop removal. Let's finish this one though. Open pit mines are usually expanded until the resource runs out or becomes too difficult to mine that it is unprofitable to continue. This method is used for copper, iron, gold, diamonds, and coal, among other resources. Similar methods are used to extract clay, gravel, sand, limestone, granite, marble, and slate. But in these cases, the pits are known as quarries. Mountaintop removal. Here's a mountaintop removal. Mountaintop removal. The method of mountaintop removal is used primarily for coal mining in the Appalachian Mountains. In the process of mountaintop removal, first the forests are clear cut and the timber is sold or burned. Then the topsoil is removed and rock is blasted away to expose the resource. Repeated cycles of blasting and extraction can eventually remove hundreds of vertical feet of mountaintop. The waste rock is transported to areas that were mined previously or to nearby valleys. So you can literally take the top of a mountain and the stuff you don't want, you just take over to a nearby valley and dump it in the valley. Kind of like a garbage dump, which is not good for the valley, but anyhow. Solution mining. Rather than removing ore from the ground, miners sometimes pump a chemical solution into a mine, such to leach the desired resources from the ore. Once the solution has reacted with the ore, the liquid is removed from the mine, taking the resource with it, as shown in Figure 10. Salt miners may use a similar method in which water is pumped into the mine, causing the salt to dissolve into the water. Then the dissolved salt and water mixture, called brine, is pumped out of the mine. So here we have one over here on the right. So what you do is you put water in here. This is a salt mine. You put water in here, and the water mixes with the salt, and then you suck the salt water back out. And you'll see that there's different layers here. So they're putting in the water. There's like multiple pipes inside of pipes. And so you put water here, and then you're sucking it out at the bottom, so that way you can continuously like keep washing it, essentially, because you don't want to just suck out all the water all at once. Placer mining. Weathering and other geologic processes can cause metals and gems to break free from their rocky origins. The loose pieces may be carried along by river currents and deposited in riverbeds. Placer mining involves sifting through material in modern or ancient riverbed deposits. The miners usually use running water to separate lightweight mud and gravel from heavier, valuable minerals. Placer mining is used in the Congo to collect coltan. It was also used in California during the gold rush of 1849 and in Alaska during the Klondike gold rush of 1897. In fact, placer mining for gold still takes place in areas of California and Alaska. Undersea mining. In a process called dredging, miners use large machines similar to vacuum cleaners to collect sand and gravel from the sea floor. Miners use other processes to extract sulfur from salt deposits in the Gulf of Mexico and phosphorite from areas near California coast. Other valuable minerals found on or beneath the seafloor include diamonds, calcium carbonate, as used in making cement, and silica, used as a fire retardant, insulation, and in making glass, as well as copper, zinc, silver, and gold ore. Although the amount of undersea metals is vast, undersea mining is quite limited because it is so expensive to access resources and extract them. Some companies are exploring hydrothermal vents as a possible concentrated, rich source of metals. Underground volcanic activity causes dissolved metals such as gold, zinc, and copper to be released through the vents. When the dissolved metals come in contact with the cold water, they crystallize and form chimneys, like this. Removing ores from the ground is just the first step in gaining access to the metals they contain. Mineral processing usually begins at the mining site. Transporting the tons of ore that are removed from the ground would be expensive and wasteful because much of the material in ore will be discarded as waste. Breakdown of ore. Minerals used to be separated from the ore to gain access to the desired metals. First, ore is crushed and ground into particles. At this point, an understanding of the compounds that make up ore is important to make sure the correct particle size is obtained. If the ore is not ground enough, then it will be difficult to separate the metals. Separation from ore. Next, processors apply their knowledge of the specific properties of minerals, including density, cleavage, magnetism, and conductivity, to separate minerals from ore. For example, because they know the densities of gold and the other materials usually found in gold ore, they can determine which particles are gold by suspending the ground ore in solution. A common separation method called froth flotation involves mixing the finely ground ore with water to form a slurry. Chemicals and air bubbles are then introduced into the slurry. The chemicals make the desired minerals hydrophobic, so that they do not react with the water, kind of like oil. Oil is hydrophobic. Instead, they attract to the air bubbles and float to the surface of the slurry where they can be collected. A froth flotation tank, as shown in Figure 13. Once separation is complete, the two products remain, the concentrated mineral and a waste product called tailings. The amount of tailings left behind can be staggering. The extraction of just a few hundredths of an ounce of gold can produce 1 ton of tailings. Tailings, which can be discussed more in the next lesson, are controversial because they lead to much of the pollution associated with mining. So that slurry is the water and chemical stuff that they float the ore in to try to separate stuff. So it's like a teeny bit amount of gold to get that out. You have to have so much of this slurry that just has to get disposed of and thrown away somehow. Steel making. These workers are going through the steps to produce steel from an iron ore in Baltimore, Maryland. So they're making steel here. Metal production. Concentrated minerals are shipped from processing sites to metal production plants. Metals such as iron, aluminum, and zinc need to be further separated from the minerals that contain them. Most metal production techniques include smelting. Smelting is heating ore beyond its melting point and combining it with other metals or chemicals. For example, to make steel, steelmakers smelt iron ore to extract iron. They then melt and reprocess the mixture, removing precise amounts of carbon and shaping the product into rods, sheets, or wires. During the smelting process, other metals may be added to modify the strength, malleability, that's like how flexible it is, and other characteristics of the steel. Steel is an alloy. Alloys consist of metals that have been melted and fused with other metals or non-metal substances. The ability to access minerals, extract metals from them, and process the metals allows us to make products that contribute greatly to modern life. But the toll that mining takes on ecosystems and the pollutants processed from processing metals have also contributed to many of the environmental problems we face today. The next lesson discusses these environmental effects and how mineral resources can be managed to decrease those effects.